Hey guys, a few days ago I posted a question in the community tab: would a Prince Rupert's drop explode if its tail were dissolved in hydrofluoric acid? The votes were 57% against and 43% in favor of the drop exploding. Creating a Prince Rupert's drop is quite simple: just drop molten glass into cold water. This process forms a tadpole-shaped drop with a long curved tail. The head of the drop is incredibly strong, you can even hit it with a metal hammer at full force without breaking it. For my experiment, I also prepared several colored drops. Their tails turned out to be quite durable, they all survived falling onto a hard surface. However, every drop shattered into countless fragments when the tail was broken. The head of the drop explodes so quickly that even my high-speed camera can't capture the moment. Breaking the tail even far from the head still causes the entire drop to explode. So for this experiment, I took a couple of Prince Rupert's drops and placed them in a Teflon cup, as hydrofluoric acid reacts with glass. Speaking of hydrofluoric acid, let me show you an interesting reaction involving it. Normally, adding acid to a metal oxide forms a corresponding metal salt and water. However, adding hydrofluoric acid to dicopper oxide also produces metallic copper along with copper fluoride, which is an interesting exception. So I used 70% hydrofluoric acid in this experiment, which quickly dissolves the thin tail of the drop. As you can see, the tail of the blue drop has noticeably shortened, and there is almost nothing left of the green drop's tail. I dipped the tail of one drop in hydrofluoric acid for a few seconds, so it could be easily broken off. Surprisingly, the drop didn't explode, and it seems lost its explosive properties. Now I'll try to snap off the remaining part of the tail with pliers, but first I'll wash off the hydrofluoric acid. It seems that after etching in acid, the drop no longer has strong internal stress. However, breaking the tail near the head still causes the drop to explode. But the green drop, which was completely immersed in acid, didn't explode when the tail was broken off near the head. It appears that uniform etching in acid completely relieved the initial stress, turning the Prince Rupert's drop into an ordinary glass drop. To make the experiment more visual, I added hydrofluoric acid to a test tube with a Prince Rupert's drop. after part of the tail dissolved, breaking off the rest of the tail didn't result in an explosion. So, to answer the initial question, will a Prince Rupert's drop explode when its tail is dissolved in hydrofluoric acid? No. But wait, let's invert the experiment. What if we keep the tail out of the acid while immersing the rest of the drop? In this case, the drop exploded, but it produced fewer fragments than usual. But I can't say this with certainty, as I couldn't capture the moment on a high-speed camera, and some smaller fragments dissolved before I could retrieve them from the acid. Thus, the explosion of a Prince Rupert's drop depends on how the drop is etched in acid. I would like you to share your thoughts on why this happens in the comments. Thanks for watching, don't forget to subscribe to the channel and if possible become my patrons, and big thanks to those who have already supported me. See you in the next video.